two 18-year-old women from Namibia. One of them, Christine Boma, stunned the track and field world by taking a silver medal in the 200 meters race. Her compatriot Beatrice Maselengi finished 6th, but their rise to the big stage has been shaken by questions over their high levels of naturally occurring testosterone.
The University of Pennsylvania's Leah Thomas, a transgender athlete assigned male at birth, dominated this weekend's women's swimming Ivy League championships, winning 3 individual events and smashing records. But does she have an unfair advantage in the pool after transitioning from male to female while in college? It's a debate that's dividing the swimming community and even her own teammate.
International Olympic Committee, the IOC, issued new guidelines stating that transgender women should no longer be required to reduce their testosterone levels to compete in women's sports. The new framework replaces 2015 guidelines that recommended trans women suppress their testosterone levels for at least 12 months to compete. The IOC also concluded there should be no presumption that trans women have an automatic advantage.
So, ladies and gentlemen, as you'll see, this topic addresses DSD and trans athletes. Now, the dividing line between men and women has proved controversial as long as we've had sporting competition, and the existence of athletes whose gender identity doesn't match their biological sex assigned at birth challenges simple categorisation of athletes, and as well, of course, how drug use has an impact on their performance. We're going to be talking about the science behind this today. I know you will have plenty of questions. Please use the hashtag SportRes2022, or we'll be coming to you on the floor afterwards. But please welcome to the stage Dr. Alan Williams.
Thank you very much for that introduction. Thank you for your hospitality, and thank you for the opportunity to speak on this topic. DSD and trans athletes, I'm going to talk about the genetics, the biology, the ethics, and the impact on the binary sex categories in sports. So my approach will begin at the beginning by talking about the typical male versus female performance differences, and then move on to the effects of testosterone suppression, particularly relevant to trans athletes. Then that also feeds on to the athletes with differences in sex development, or DSDs, and that in turn leads on to some reference to the eligibility regulations and the testing, which in turn leads on to some quite substantial ethical concerns. And then I'll try to make some suggestions about research, some hope about how to inform policy and perhaps individual cases, and then reach some conclusions at the end, which I would of course base on the scientific evidence as much as I can, but inevitably it's partly going to have my opinion to it. There's no way of divorcing those two. So I'll start at the beginning. The typical male biological advantages, just a few key parameters are shown here. So you can see that limb length is about 12% longer on average in males than females. Muscle mass, more than that, maybe around 37%. Muscle strength, even more again, more like 50% or more. And cardiovascular function related to endurance performance, something like 25 to 30%. So those are really very substantial. But of course, in most competitive sports, you don't get a medal for having long limbs. You actually have to do something with those characteristics. So here are equivalent data, I suppose, shown in a slightly different way. What we have are the male advantages in a variety of sports or sport actions, which are shown along the bottom here. And on the left-hand side, we have things like rowing, swimming, running, and cycling. And that includes events that are classed as sprint activities through middle distance through to endurance activities. And the typical male advantage there is probably around 10 to 15%, something like that. Then there's a variety of other performances, things like tennis serve, cricket bowl, baseball pitching, and so on, with the male-female differences heading towards 50%, perhaps even more than that. There really is a mountain of scientific evidence that supports that. These are data that have been reviewed extensively, and they go back many years in many different studies. So why do those typical male versus female differences exist? And the answer in a nutshell is genetics. And specifically, so remember, those of you who aren't scientists, remember some school biology maybe, some school science, then the main chromosome difference, the main genetic difference between typical males excuse me, and typical females is the presence of the Y chromosome in males and 2 X chromosomes in females. And the Y chromosome then contains a gene called SRY, which stands for sex-determining region Y. And that gene, its job, if you like, is to produce the SRY protein, otherwise known as sex-determining factor. And that protein, its job is to encourage the development of testes rather than ovaries in the developing fetus. And then it's those testes that then produce testosterone at a significantly higher level in males and females, particularly during puberty, but also at some other points in life as well. And that testosterone, this is the last bit on the slide, that testosterone then stimulates an additional growth of the skeleton, hence the limb length, of muscle, of the organs related to exercise, like the heart and the lungs, and raised blood hemoglobin concentration, which is probably the key protein found in blood, which transports oxygen around the body and is key for endurance performance. So to put the effect of all that in context with other genetic differences that are sometimes referred to in this debate. So a large part of my personal research and my research team is to try to identify genetic characteristics that give certain athletes advantages over others in terms of their performance, not particularly related to the sex category debate, perhaps. So there are some examples on this scale here. There's one, there's a gene called ACTN3, that if you have a particular version of that gene, it probably makes you a slightly better sprinter than if you have a different version of the gene, by about 1%. Doesn't sound like much, maybe? Doesn't sound like much, maybe, but could certainly make a difference between winning a gold medal in an Olympic sprint final or probably not even making that final. On the other end of this scale, there is a gene called EPOR, which is the erythropoietin receptor gene, and in one Finnish cross-country skier, he and his family had a mutation in that gene which massively increased the amount of hemoglobin he had in his blood and almost certainly contributed to his multiple medals, including golds in cross-country skiing at the Winter Olympics. And that probably gives an advantage of in excess of 30% in endurance performance. That is a very rare mutation. But in that context, then the Y chromosome and the SRY gene that is on that chromosome that I referred to probably gives an advantage of around 12%. It does depend what type of sport performance it is you're thinking of, but it's something of that order. So it doesn't look outlandish on that scale. It's not, it's not significantly more than any other genetic variation that we know about that also affects sport performance. It fits in that range. But there is, of course, one major difference for the Y chromosome compared to the others. So for the others, like ACTN3 and EPOR on the screen, they are equally likely to appear in men or in women. So they can affect performance, they and others can affect performance within the sex categories, but they are not the basis of the difference between the sex categories. Whereas the Y chromosome and the SRY gene and its effects on testosterone are in fact the cause of the difference between most men and most women. So, as it says on the bottom there, that advantage is only available to males, to most males, and not to most females, and that is the key difference. And fundamentally, that is why separate sex categories in sport are essential. If you do not have that, then everybody who was successful in sports that have a significant physical component, whatever that physical component is, would have a Y chromosome, and that would be almost exclusively men. So we go to testosterone levels. So this figure shows, there's quite a lot on here, I'll just try and talk you through it. On the top two bits to focus on male. So these are typical males, and these are typical females, and this is testosterone concentration. In fact, it's not a linear scale here, it's a log scale, so if anything, the difference there, and there is clear blue water between those two groups, if anything, the difference has been foreshortened by the scale of the graph. So there is that clear blue water in terms of testosterone levels between most males and most females. I'll come back to those in a second, but just briefly, I haven't really talked about athletes with differences in sex development much yet, I will in a moment, but these represent different categories of athletes with a DSD, and you can see that they are less neatly contained in terms of circulating testosterone. So just note that, but I'll go back to the top two parts, that clear blue water, and in terms of the eligibility of trans athletes, and specifically trans women athletes in a female category in sport, I think quite a reasonable proposal is that, well, if that represents the difference, normally, then if you take someone who is a typical male genetically, and you then reduce their testosterone level to something like the normal female range, then that could potentially remove performance difference, the performance advantage that they have, and then maybe they would be able to have a level playing field in terms of competition with females. Unfortunately, it's not quite as simple as that. So again, there's quite a few studies just in the last few years that have looked at this topic, and just this is a summary of some of those. So while muscle mass by about 5% and strength by a similar amount do seem to reduce in trans women following around 12 months of testosterone suppression, those reductions are much less, significantly less than the typical advantages in muscle mass and strength in cisgender men. So that performance advantage is the evidence to date suggests that that is not removed. So there's clearly a tension then between how one approaches sport in terms of the quite laudable aims of inclusion of those individuals whose gender identity differs from their biological sex, so trans women in this case, in the female category, and the fairness and indeed safety in some sports where there is contact between individuals, and particularly in combat sports perhaps even more so. There is that tension between inclusion versus fairness and safety. And in the short video at the beginning, which I thought was nice, by the way, because it didn't get too personal and sort of handled things sensitively, the fairly recent IOC framework was mentioned, which my reading of that is that what was notable by its absence was a failure to recognise that tension between inclusion on the one hand and fairness and safety on the other. So there are some symbols just on the end of this statement, and these are my caveats, and there are a few. So there is very little evidence from well-trained trans women. So the evidence so far is from people who are less well-trained, not really what we call athletes. There is very little evidence in sport-specific actions. There's sort of fairly generic measurements that we might use in the laboratory or in the field, and not so that there's no data on rowing, for example, or from actions particularly related to tennis or other sports. And there is very little evidence when testosterone is very strongly suppressed, and particularly for a long period of time. So you can gather from that, I think, that there is some scope for research which might produce evidence which actually does show that in certain circumstances, then reducing testosterone for a prolonged period of time in athletes and using sport-specific measurements might show, and perhaps show convincingly, that the male advantage can be removed by lowering of testosterone. I'm not saying that's likely, but it's possible in some circumstances. So believe it or not, that was the simple one, the case of trans athletes. The more complex one is then the case of athletes with differences in sex development, or DSDs. So the World Health Organization states that most women are 46XX in terms of their chromosomes, and most men are 46XY. Key word in this statement is most, because then there are some individuals, the most is about 1%, it's probably a bit less depending how you define things, who don't fit those categories. So in fact, there are not only females who are XX and males who are XY, but rather there's a range of chromosome complements, hormone balances, and phenotypic variations that determine sex. So there are examples where people have different numbers of sex chromosomes. In fact, it's not just the Y chromosome and the SRY gene that determines sex development. There are a whole range of genes that work sort of together in a complex way, and there's crosstalk between them. And those genes are then found throughout the genome, so not just on the Y chromosome, for example. They are found across a number of genes. So a variation or a mutation in almost any one of those genes can affect sex development in some way. And this is why there is a great variety of DSDs. Some are listed there. And there's even some quite remarkable cases of that increasingly found to probably not be as rare as was thought previously, of even within one individual, then having different genomes within different cells in their body, known as mosaicism and clanidism. So it's extraordinarily complex. I don't know if you remember that detail that's on the screen, but my point is that it's extraordinarily complex. So with that in mind, then organizations have tried to develop their policies. So typically in sport, we have male and female categories, but the genetic and biological reality of those individuals with those DSDs is that there's a small number of people, but a substantial number, I would say, who have DSDs that really challenge that border between the male and female, or the boundary between the male and female categories. So again, more complex biology is a biochemical pathway. I'll just point out cholesterol at the top, you probably heard of, but maybe you didn't realize that it was a key precursor to the production of testosterone down here. And just a reminder that male levels of testosterone are very much higher than in most females, because this pathway is very much more active in the testes of males, so we produce more testosterone. Each one of these blue and red symbols represents an enzyme which catalyzes a conversion from one protein to another in this pathway, and each of those enzymes in blue and red has a gene, and each one of those genes then is susceptible to having a variation or a mutation within it that can affect how this pathway works, and therefore the amount of testosterone that is produced, and how that is handled by the body, and how it is metabolized. So again, I'm just making the point that these things are extraordinarily complex. Just to pick on just one of them, and I could pick on others, but one of them is 5-alpha reductase. So that is an enzyme, a protein that converts testosterone to another protein called dihydrotestosterone, also known as DHT. And it's a little controversial, but DHT itself has some direct effects on muscle function. So if someone has a mutation in the gene that makes this protein, then their ability to convert testosterone to DHT might be completely removed, or it might be partly removed, or it might be only removed to a very small extent. So even just in this one point in this pathway, there can be very different manifestations of this in an individual. And just to make that even more plain, if I can, so this is a structure of a gene. We might be trying, this is a simple structure of a gene, where we just sort of group large bits of the DNA into blocks, those are the exons, and all these different entries are an individual in the scientific literature who has been reported as having a mutation in the one gene I've been talking about. And the reason that there are all these different ones is that almost no two individuals have the same mutation. So they have very individual genetic characteristics which affects the function of this enzyme to different degrees depending where it is. So if you've got a nonsense mutation early in the gene, then almost certainly you've got complete knockout or no function of that protein. If you've got a missense mutation later in the gene, then it's more likely to have a smaller effect. But again, the point is just there is huge variability here. So with that huge variability in mind, then organizations such as World Athletics, and to be fair to them, I think they are probably have the most developed regulations in this regard, but they do group together many different DSDs under one set of regulations. So I was showing you the example of just that one at the top. But there are many different ones. There's even a catch-all phrase at the bottom, any other disorder that fits this category. So these regulations apply to somebody who genetically fits one of those listed there. Also, then that individual would need to have a testosterone level of 5 of those units, so that's in that sort of normal gap between the male and female levels. And both those things, the genetics and the testosterone level, could be assessed fairly, relatively simply from probably just a single blood sample. But I would contrast that simplicity with the third criterion, which is that the individual has sufficient androgen sensitivity for those levels of testosterone to have a material androgenizing effect. Those last 3 words, material androgenizing effect, to assess that is now an extremely complex and invasive clinical assessment of an individual, and I will refer to that in a few slides' time, but note that it's part of the criteria. Leaving that for a moment, so if an individual does fit those criteria, those 3, then currently, of course, within athletics, they are not allowed to compete in the female category without reducing testosterone in track events from 400 meters to 1 mile. So you can compete without lowering testosterone if you fit those criteria in 200 meters or 3,000 meter steeplechase, for example, and longer distances, which is an anomaly, I would say, certainly. And the reason for that is largely based on this paper. The events don't quite match, but this paper published 2017, I believe, documented the relationship between testosterone levels in women and their competitive level performances. Unfortunately, however, that paper has been very, very heavily criticised since it was published. There was a correction by the authors published just last year, where they at least acknowledged that there is no confirmatory evidence for causality in the observed relationship between testosterone level and performance. They acknowledged that it was not possible to adjust for potential confounding factors, which are huge because these are not laboratory controlled studies, these are field data where things aren't controlled. In fact, there are many more criticisms which I could refer you to a paper that does that quite destructively. So that's one key paper on which the regulation is based. There was another that I was really still amazed that it was cited so strongly, and this was a single author paper in a quite respectable journal, but it's an opinion piece, so it's not a formal research study. It doesn't have the universal approach of having an introduction, a method, a results section, and a discussion. So it's just somebody writing about something, and in the middle of that article there is one figure, which, as I say, was cited in support of the World Athletics regulations, and that figure is purported to show the effect of testosterone reduction in athletes with a DSD. And this is before treatment, this is their running performance, that's 100% of their sort of pre-treatment value, and then it lowers by a couple of percent after 1 year and lowers a bit more after 2 years. But as I say, that it's not in the standard scientific format. There is no method section, so no other scientists can peer review the way that was done. There are no statistical analyses. It's just a figure, no t-test, whatever statistical analysis you want to do, those don't exist. And it's based on 3 individuals. And we don't know if they're the same people, but Human Rights Watch have reported that the same type of individuals at around the same time were undergoing this scrutiny, targeting and testing, which had profound negative psychological repercussions, and quotes from some of those athletes directly, saying things like the hormonal drugs made me feel constantly sick. So those types of things are very clear confounding factors and hardly seem compatible with maintaining the same training volume or living the lifestyle of an elite athlete. So I think it's hardly surprising that the performance might reduce like that when all this is going on. So there's no measurement of even training load, which is pretty fundamental. So I'm still flabbergasted that was cited quite prominently by World Athletics. So I think a key question is, do DSD women have the same biological sport performance advantages of most men? And there are 2 schools of thought. One school is that, well, yes, they do. This is a biological certainty. They have a Y chromosome. So if they have a Y chromosome, if they have testosterone in the typical male range, and it's sort of based on the assumption that that response to testosterone is indeed measurable, then yes, they are equivalent to to most men in terms of the biology of sport performance. The reality, in my opinion, and that of certainly others as well, is that there's in fact substantial biological complexity of the DSDs with highly individual, rare genetic characteristics, as I tried to show, that testosterone is not always in the typical male range, and that that response to testosterone is, and related hormones, is variable and is in fact very difficult to measure. So in summary, the existing evidence regarding DSD athletes is extremely limited and problematic, as I hope I've shown. Not only that, but then there are very substantial practical and ethical problems that I'll move on to now. So, staying at the top there by the British Medical Association is that a fundamental ethical principle regarding medical practice is that no examination, just pause on that word, just an examination, never mind diagnosis and then treatment of a competent adult should be undertaken without that person's consent. And it goes on to say that that must be voluntary in terms of not being coerced. And the reality is that when competitive athletes are presented with regulations that require them to be assessed and then to undergo things like testosterone suppression in order to compete, that is considered by many as in fact being coercion. So it is not entirely voluntary. There was a session this morning and I asked the question, we didn't get to have a discussion. But in the WADA code, and in 2019, action on page 146, I looked at this morning of the WADA code, there is a small footnote, which is certainly not very prominent, which says that samples gathered during anti-doping procedures may be used to assess eligibility for sex categories. So it didn't exist prior to 2019, but samples were certainly being used for that purpose. And now it is at least included, not very prominently, and there have been calls, as cited there, for it to be removed on the name of human rights. I mentioned before that the DSD regulations of World Athletics apply if someone has a particular type of DSD in their list, has testosterone above a certain level, and then that testosterone has a material androgenizing effect. And I said that the assessment of that is much more extensive. So you have to look hard actually to find this information, but you have to go from one document to the other, but then you get to the answer of how a material androgenizing effect is assessed. And it's by looking at those characteristics on the screen I'm not going to read out, other than to say that the only one, according to my exercise physiology textbooks that I have on my shelf, the only one that's related to sport performance is muscle mass. The others are not. And it seems to me that sports medicine professionals have no business looking into those other things when they are considering performance issues in athletes. And I can guarantee that just assessing muscle mass alone would not tell you whether someone is responsive to androgens or not, because there is very much an overlap in terms of muscle mass between men and women without even getting into particular individuals. Not only that, but then there is the pressure to undergo medical procedure or interventions despite no ill health, which is the World Medical Association has stated very clearly in relation to this specific issue, is contrary to medical ethics, and they want to say that a medical treatment is only justified when there is medical need, and these people are not having treatment for an illness, it is for sport eligibility purposes. So, in terms of, so I think one of my messages is that the scientific evidence base is lacking in several respects. So this slide is trying to say what could be done to improve that evidence base and improve the basis on which policies can be developed. So regarding trans athletes, as I mentioned before, then the effects of strong testosterone suppression in trans women, well-trained athletes, using sport-specific measurements. I'm doing that if required, even for 2, 3, 4 years. That's the kind of research that could provide evidence that would support an inclusion policy if people would be then satisfied that a reduction in performance that is equivalent to the typical differences between men and women in that particular sport could be shown to occur. Currently, that evidence doesn't exist, so that would be useful, I think, in this whole debate. For DSD athletes, we're not even at that point. We're a step back from that because they're just purely their biological characteristics as relate to sport performance and not being described. I understand why, because there's not many of them, and many are maybe not in countries that have kind of active sports science or sports medicine research departments and that kind of thing. But the kind of research that would give some data here are to assess performance-related biological characteristics in a specific type of DSD, and you can't just put them all together as one. You have to be on a particular type and then perhaps another type. And if they were voluntarily suppressing testosterone, then that would provide an opportunity to assess those things longitudinally as well. For either of those, then engagement, serious engagement is going to be essential with representatives or advocates of those athlete groups and the individuals themselves, because you're going to need voluntary informed consent. And as I said, the different types of DSD are very rare, so if someone has something, then they also become very valuable to you as someone running a research study, because they are really important for your study to show some data that are conclusive. So I'll try and draw some conclusions. As I said at the beginning, this is influenced by my understanding of the data, but inevitably it's partly my opinion as well, based on discussion with many other colleagues as well, I should add. There was quite a bit of text. I don't normally write much text on a conclusion, but I thought I should. Testosterone suppression in trans women probably doesn't remove the male advantages or normalize safety concerns. So eligibility of trans women for most female sport is not currently justified if you wish to maintain that fairness and safety in sports where that's relevant. I think the second part there is the proviso to that perhaps some more research about sport-specific data from athletes undergoing strong suppression might change that situation. But at the moment, and choose my words carefully, the scientific burden of proof, because I got ticked off by somebody who's saying burden of proof, and I didn't know that had a particular meaning in legal circles. So the scientific burden of proof, I think, is on the side of having to show that testosterone suppression is sufficient to level the playing field, rather than assuming that at this stage. Second conclusion is that rare genetic features in DSD women really challenge that male-female eligibility boundary. And existing sex testing policies are variable, as many of you will know better than me, and even the most developed, I'm afraid, is based on poor quality, or at the very least highly contested scientific evidence. And furthermore, the invasive policing of those biological characteristics and hormonal or even surgical interventions not performed to improve health contradict basic ethical procedures. principles. So my final conclusion, even though I'm a biomedical scientist, geneticist, sports scientist, each or bits of those, my conclusion tries to make this whole issue less biomedically orientated in terms of how things can proceed. So it's informed by all the evidence that I've reviewed, but my suggestion is that individuals recorded, again I'm choosing my words carefully, recorded as female sex at birth who have always lived and competed in sport as girls or women should be eligible for female sport categories. I think you can follow that through then in the case of trans athletes and what that means, and in the case of DSD athletes and what that means. So I welcome any questions. I will stop there. Yes, interested to hear what people think.
Look, it is a complicated issue, and I'm really interested to see if we have some questions from the audience. Primarily, from my point of view, when we're reporting on things like this, you said it yourself, there's so much conflicting evidence, and when it comes to science, you sometimes hope that's the one thing that you could rely on, but we're seeing it time and time again where these bodies, World Athletics being one of them, they make their cases and they bring this evidence, and then it's had to be retracted, and it's really difficult to try to keep up from, to try to keep yourself educated when you haven't got a science background.
Yeah.
How do we deal with this? We're reporting on this, and where does this go? It means that there's not really any right answer.
Yeah, I think to summarise it, yes, I think you've got a difference in timelines between the scientific evidence being produced that you would like to have. It's easy for me to say, well, we'll just do this study and that study. It costs a lot of effort, a lot of time, and participation of lots of different people, versus trying to deal with what sports are faced with right now in terms of trying to keep that level playing field and also being aware of inclusion issues and trying to do both those at once. So I think the issues have appeared. Maybe someone could have thought forward a bit more, but the issues have appeared before the science has been done to a satisfactory degree. So I understand that federations and sports are then trying to do the best they can with that. Which is why I think my final conclusion was trying to say, well, right now, based on the evidence right now,
scientifically speaking,
as much as it's informed by the science, but it's still trying to find a practical solution. I just think that is a better solution than the convoluted biomedicalization of the whole process, and then you dig down into the science, and as you said, then it sort of falls apart on that basis. So.
Do we have any questions from the floor at all? Please raise your hand if you do. Yeah? No.
Just two questions. First, Stebbings, you mentioned Stebbings a lot. I think I'm correct in saying that's the USAF, the US Air Force study over 3 years, is that?
No, the Stebbings at our reference, that's the British Association of Sport and Exercise Sciences. So that's just a short sort of expert statement document. But I know I'm aware of the individual study that you're mentioning.
Thanks for that. The thing that struck me when you were speaking was, would you say it's a fair summary that there are different ethical and scientific challenges presented by trans athletes compared to DSD athletes, and that policies such as the IOC's one, which treats trans athletes and DSD athletes under the same rubric, is perhaps, it might be improved if those challenges were addressed separately rather than under one overarching policy. Could you comment on that?
Yes, so I absolutely convinced that they should be considered as separate issues, although I've just talked about them both, because people do think about them together. But yes, you're right in terms of the science and sort of the biological science, but also the human factors. There are very different contexts. So yes, I think in terms of how that gets translated to policy, they should be treated very differently or considered separately. Yes.
Any more questions? Yes, just over here to the left, yeah.
Can you hear me? Oh,
Loud and clear.
yeah, thank you. Sorry about that. So I understand that two pillars of sports are inclusion and fairness, right? But inclusion meaning that we have to ensure that all people can participate in sports to the extent possible. And fairness is basically same ground level for everyone to compete. From a practical standpoint, to ensure that those two principles are observed, do you think that discussion about a separate league or a separate Olympics for trans athletes would be a good way to start a conversation, so we can include those individuals in a manner that create the same ground level to every single individual participating in the sports, the same way we created that ground level with the Paralympics sports.
Yes, so your last comment there, sort of drawing a parallel with the Paralympics, I think that's a reasonable parallel to make. I think, so I'm not I'm not in sports governance and so on, but I think that's a reasonable suggestion or way forward. My hunch is that some of the individuals affected by that then perhaps wouldn't be satisfied with that. That maybe is not then perceived as proper inclusion. So yeah, how that would work through, I'm not sure, but I think it would fix one issue and perhaps create another one.
Yeah, I think from your point of view, Dr. Williams, in terms of the science, it's very hard for you to comment on that, and I know it's a hard one to ask questions about, because there are so many different ways that we could sit here and try and find a solution, but of course we don't have anyone to represent the other side of the argument, and as you rightly say, those affected by this would probably disagree with a sentiment like that, so it's a difficult one, I appreciate that. Thank you for your question. Any other questions, please? Yes, just there. Let me just get the microphone over. Thank you.
As someone who's been a sports doctor and been looking after professional science for 20 odd years, in rugby and football, what I'm interested in is why couldn't we use for the trans people say that your category is based on your sexual at age 16 or at puberty, and therefore if you're at 16 you're a female, then you're trans when you're 22, 23. The rule states that at 16 you're a female and therefore you're going to be in the female category. Wouldn't that be some way out of this very difficult situation?
I see the idea. I think you suggesting this is after puberty?
Well, the age is to be decided. I mean, I'm just using around puberty time. And then you at least say, well, if you're trans, fine, it's absolutely wonderful. But, as far as your category go into, you go in, whatever data scientists like yourself decides, the opposite. But I meant the opposite, right?
Yeah. In the UK, my understanding is that the Gender Recognition Act, for example, someone has to be at least 18 to change a birth certificate. So if that was an age at which, or just before that, for example, then I think that would essentially be doing what I think I was proposing anyway. I said at birth, but if it was at a point before someone completed that change of gender, then I think the end result might be the same, if I understand correctly.
Sorry, go ahead.
I
support, that's all. Interested in your opinion. Yes.
Because you even mentioned before, puberty seems to be the kind of the turning point here, so that kind of
yes.
falls into that.
Yes, I think that's sort of the key, in terms of sport performance, the key period of time by which those typical male versus female differences occur is during puberty. There's some evidence that some things happen probably a lot earlier than that as well. Maybe some effect on the number of skeletal muscle fibers somebody might have, which might sort of affect their training responsiveness as an adult. And also some things related to brain function as well in some ways. But yeah, the main thing is puberty, yes.
Final question, if anyone, because we are short on time now, I appreciate no, which is perfect, and it means I don't get told off. Thank you so much, that was really, really interesting. Again, it's a conversation that we could continue, but for now, Dr. Alan Williams, thank you.